Mm-mm. Try the shortcut. This is easy. Baby stuff. We're Boy Scouts.
Well, my mind don't work this way.
Tic-tac-toe. It's a piece of cake upside down. Watch for the green light.
I've been with you guys 2 years. Everybody knows I'm the dumbest. I can't handle calculus. These guys have a better chance of making the AP test without me. Don't laugh.
How could we laugh? You're breaking our hearts.
Don't do this, Kimo.
I mean, how noble. To sacrifice himself for the benefit of the team. Do you have the ganas? Do you have the desire?
Yes, I have the ganas.
Do you want me to do it for you?
Yes.
You're supposed to say no. Well, I'm gonna have to get tough. Bullets are gonna have to start flying. We're gonna have to work right through Christmas break, okay? The counselor was just here looking for you. Something about some cosmetology classes. He says there's 3 different levels. One for boys, one for girls, and one for I don't know what kind. Why don't you go find out?
No, Kimo, please listen, man. It's cool. My grandmother.
Clock out. Game's over, you lose.
You never listen to nobody, man. Te crees el más chingón.
Adios. Why don't you send me some postcards? Or call me on the telephone. Let me know how you're doing. We love you.
Kimo sabe this, cabrón, huh?
Pancho, I think that guy's got a bigger problem than you. Tick, tack, toe. Simple.
So as you can see in that video, he did a new integration technique that we are covering in our new unit, Unit 8. Unit 8 is advanced integration techniques. So these are the techniques of integration that we only do in BC. So in 8.1, we're going to do integration by parts, and that's what we saw in the video from Stand and Deliver. In 8.2, we're going to do trig substitution and integration that deals with finding integrals of trigonometric functions. 8.3 is going to be integration by partial fraction decomposition. 8.4, we go back to L'Hopital's rule that we covered in AB. And then 8.5 is improper integrals, where we use some of the stuff that we've done in L'Hopital's rule to finish up the unit on 8.5. So a shorter unit, but very, very important concepts that you will definitely see on an AP exam and obviously on our exam in class. So I'm going to share my screen here and show you in our notes here. The integration by parts comes from taking the derivative of the product rule. So if we take the integral of the product rule, we basically come up with this, this formula that we call integration by parts. So whenever we have two functions that are being multiplied together and we're integrating it, we use integration by parts. Okay, so in the example that he did it in the video, it was x squared times sine x. Okay, and you will notice that down here we do a variation of that with x times sine x. Okay, now this you need to make sure you memorize. So we came up with this funny little acronym, which is ultraviolet voodoo. And basically, you're taking the integral of u dv is equal to uv minus the integral of v du. Okay? And that is what integration by parts is. So you will see in our examples here that we have to choose a u and we have to choose a dv. Okay? And that is what we're doing to do integration by parts. So we have to let our u be one of the functions and let dv be the other function in terms of dx. So one of the best ways to figure out what to make your U is to follow this another acronym that is LIATE. And this acronym basically goes in order of what to make your U. So we go down the list, we go logarithm. Does one of our functions, is it a logarithmic function? Is it an inverse trig function? Is it an algebraic function, trigonometric function, or an exponential function? So we go down that line to choose what our U is going to be. Now, this doesn't always work for every single case. There are some exceptions to that, but keep note of that this is a very useful trick. So down here, what we did was we're going to let our U be X because algebraic functions come before exponential functions in our acronym of LIATE. Okay? And so we let U be X, just like we do U substitution, our du would be dx. And we let dv be our function e dx dx. And how to find v is we integrate this. So we're going to integrate e dx dx, and it's going to give us e dx. And what you're going to do is you're going to do the tic-tac-toe method here, where you're going to take u times, you're going to take uv, u times dv gives you the integral of this, and then you're going to take your uv, which is x times e to the x. So it's going to go like this. It's going to go uv minus the integral of, in this case, voodoo. So that would be v du. So it goes like this. Okay? So you're taking uv minus the integral of v du. And so that's how I got this x times e dx minus the integral of e dx dx. Then this becomes easier to integrate. We're going to take the integral of e dx dx. Okay? And so if you look at this example here, we're doing another one. We choose the natural log, which is a logarithmic function, before doing the algebraic. So we're going to let u be the natural log of x. Du would be 1 over x dx. Our dv would be the x squared. So we take the integral of x squared dx. That gives us 1 over 3x cubed. And so we just go uv minus v du. Okay, so we go just like that. And we're then going to be able to integrate. And from there, when we integrate this guy, we end up getting this answer here. Okay, so play around with some of these examples here, especially taking the integral of natural log of x. That one is a very interesting one where we let u be natural log of x and let du be 1 over x. Our dv would be 1 dx. Okay, so try that. We'll do some of these in class. Jot down any questions that you may have. And I want to move on to, obviously we can do repeated integration by parts. And this is the example that was in the video, where we may have to do it multiple times if we end up getting an integral of two functions that are being multiplied together here. Okay. And then there's this other method that is called integration by parts using the tabular method. This is our tic-tac-toe method, where we start with our sign of plus, and we let our u be our x squared, and let dv be sine 4x. And what we're doing here is we're taking the derivative of each of these, of u and the derivative dv. And then from there, we are, then we're right there, and then we are able to solve this, okay? I think in dv, you're going to integrate this. Yeah, this looks like you're integrating this. So you're gonna take the derivative of u, and then you're gonna take the antiderivative of dv. And that's gonna give you these guys. And then you're just gonna do the tic-tac-toe method, kind of like we did up here, where you're basically doing that. You're doing the tic-tac-toe method, but just in a table form. Okay, so this works pretty well when you have function, like different types of functions that are being multiplied together, like a trig function and an exponential function, or an algebraic function and a like a logarithmic function. Okay, so try to do that. Try to do some examples of 8.1, and we will go through some of these together. If you have any questions, we can answer those. But make sure you do your homework over this section. This is a new concept, and it's very important that we get this because it's a big piece of BC, is being able to do integration by parts. Okay, so I look forward to seeing you in class, and have a wonderful day. And I can't wait to do some integration by parts with you. Have a great day. Adios. Bye.